Hello everyone, welcome back. This is Engineer Hussein. So in this video, we'll be continuing from where we ended in our NQNS math revision. Alright, so before we begin, do not forget to like and subscribe to the channel. Alright, so the question reads, let f of x equal to x over x plus 2 and g of x equal to 2x minus 1. Now we need to verify that f of g to its inverse is equal to g inverse of f inverse. Okay. So we need to verify that f of g inverse is equal to g inverse of f inverse. So we're having a function on our left hand side. So we have the left hand side being equal to the right hand side. So we need to make sure that what's on the left is equal to what's on the right. So do up a data for one side. Alright, so we're having the left hand side. On our left hand side, we're having f of g inverse. Now this can also be written as f of g of x to its inverse, like that. So this means that in the f function, wherever there's x, plug in the input of the g function. This implies that f of g inverse will have to be solved by first finding f of g, the Fogg function. So that's what we're going to do first. So let us first determine what f of g is. So this means that in the f function, wherever there's x, I plug in the g function. Now the f function is given as that. So wherever there's x, I'm plugging the g function, which is this. So I'll have 2x minus 1 over 2x minus 1 plus 2. And this will give me 2x minus 1 over 2x minus 1 plus 2. So f of g of x in particular will be 2x minus 1 over 2x plus 1. That is what we're going to have. Now this is only the f of g of x function. Now we need to find the inverse of this in order to have what we want. So now to find f of g inverse, we first have to let the function, which is what we found here, which is f of g of x equal to any variable other than x. In our case, we use y. So this implies that this entire portion here is going to be y. So we have y is equal to 2x minus 1 over 2x plus 1. Then we have to solve for x. Now this is basically having over 1. Once we cross multiply, we'll have 2x minus 1 being equal to y times 2x plus 1. So we have 2x minus 1 is equal to y multiplying 2x, you get 2xy. Y multiplying 1, you get y. So now we need to put the x's on one side of the equation. So we're going to put 2x, then this will go the other side, and you have minus 2xy. Then the minus 1 will go the other side, and is equal to positive 1 plus y. If we factorize x, because our interest is x, so I'll just push it here. If we factorize x, we'll have x, then we'll have 2 minus 2y being equal to 1 plus y. Remember, our interest is to find the value of x, so we divide both sides by 2 minus 2y. Even this side, 2 minus 2y. this gives us x being equal to 1 plus y over 2 minus 2y. This simply means that the f of g inverse of x, or rather, even without the x, because in this case, we're having the y's, so we just have to substitute wherever there's y and put x. So you can say of x, if we want, is equal to 1 plus x over 2 minus 2x. Now, be mindful that this doesn't necessarily mean that if one person writes, say, or let's say you decide to just write the fork inverse is equal to, let's say, 1 plus x over 2 minus 2x. This is also correct. It is fine. So just be mindful about it. So this is our f of g of inverse of this particular part that we're looking at, which is the left-hand side. Now we're going to look for the right-hand side. So I erase this portion. All right, so we have what we need for one side, which is the left-hand side. So we're going to do up a data for the right-hand side. The right-hand side needs the g inverse of f inverse like that, which means that this can also be written as in the g inverse function, wherever there's x, plug in the f inverse of x function, like that. So basically you need to find the g inverse function and the f inverse function. So let us do that. So let's look for data that is for the g inverse of x function. So in order for us to find the g inverse of x, we literally have to use the g function, which is g of x being equivalent to 2x minus 1. Now what we're supposed to do is to let the function that we have, which is g of x, equal to any variable other than x, which is y. So we're going to have this entire thing turn into y. So we're going to have y is equal to 2x minus 1. I can flip the equation mathematically, we are allowed. So we're going to have 2x minus 1 is equal to y. After that, we have to solve for x. The minus 1 goes the other side, and you have 2x being equal to y plus 1. Now, remember, we're looking for the value of x and not really 2x. So we divide both sides by 2. By doing so, we have x being equal to y plus 1 over 2. Now, what we necessarily have is not the value of x, but rather the g inverse of x function, which is, remember, wherever there's y, substitute with x, and we have x plus 1 over 2. So I'll put this, let me erase this portion because we already used it. So I'll put this as my data for g inverse of x. It's by the side. So I found our g inverse of x to be this. So g inverse of x, or just the g inverse function. Remember, even if you write the g inverse function, you're speaking the same language. So this is x plus 1 over 2. Now, once we do that, let us also now try and find the f inverse function. So let us find the f inverse function. So to find the f inverse function, we're going to use the f of x function, which is equal to x over x plus 2. Then we have to let the function in question, which is f of x, equal to any variable of our choice other than x, which is now y. So basically we will have y being equal to x over x plus 2. Solving for x simply means we have x, because this is over 1, is equal to y times x plus 2. And we have x is equal to xy plus 2y. Now putting the x's on one side, I have x minus xy being equal to 2y. Factorizing x, we have 1 minus y being equal to 2y. Dividing both sides, I have 1 minus y, and then this side 1 minus y. That cancels out. In turn, I'll end up having my f inverse of x function to be equivalent to 2x over 1 minus x. So this basically means that f inverse of x function is equal to 2x over 1 minus x. Now, I need to verify the initial condition that we were looking at. And that condition is that we need to solve the right-hand side. So in the g inverse function, wherever there's x, we'll plug in the f inverse function. So the g inverse function is here. So wherever there's x, so I'll just pick it up from there. Or rather, I can just write whatever we were given to find is equal to, wherever there's x, I'll plug in this function. So we'll have 2x over 1 minus x plus 1. And this will be over 2. Then I can deal with the numerator because it looks a bit messy. So I can just say data for the numerator. So 2x over 1 minus x plus 1 over 1. Common denominator to be 1 minus x. Then it should be 2x plus, expressing a fraction, two fractions as a single fraction to give you 1 minus x. And this will be x plus 1 over 1 minus x. So this is the numerator basically. So having the numerator as x plus 1 over 1 minus x, and this is over 2. Now, with that done, we can say g inverse of f inverse is equal to x plus 1 over 1 minus x, and this is divided by 2 over 1. So g inverse of f inverse is equal to x plus 1 over 1 minus x times 1 over 2. So this is g inverse of f inverse, you could say of x if you want, or you can just remove it and forget about it and just write it like that, is equivalent to x plus 1 over, 2 multiplies each entity because it's same as 2 multiplied by that, written like that, which is x plus 1 over 2 minus 2x. Now this is the value, so I could say, okay, my g inverse of f inverse is equal to x plus 1 over 2 minus 2x. Now remember, we're trying to verify that the left-hand side is equivalent to the right-hand side. So the left-hand side gave us this, and the right-hand side gives us that. Now, are these the same things? Yes, they are. Because I know others might be thinking that because we're having 1 plus x, and here we're having x plus 1, it's different. No, it's the same thing. It's the same thing, literally the same thing. So we're having, this implies that we're having 1 plus x over 2 minus 2x being equal to the same thing, which is 1 plus x, picked up from there, over 2 minus 2x, which means that this particular function question has been verified. And that's how you go about solving it. Alright, thanks for watching. Remember, slow progress is better than no progress. And let's strategize before becoming a statistic. Let's push for that A+.